Start with the name of Allah, who is the most beneficent and the most merciful. Today I am back with another topic, that is radioactive isotope and radioactive decay. Let's discuss what is radioactive isotopes. Radioactive isotopes are simply the unstable isotopes that decays over the time. Here is a simple definition for the radioactive isotopes. Several isotopes of the same elements exist whose nuclei are unstable. These isotopes have a nucleus which is very unstable. Unstable means that they do not exist for a lot of time. They decay over time. They have a very short life period. So whenever they decay, they emit excess energy in the form of radiations, heat, whatever we can see. So whenever they decay, they release energy, and they release energy in the form of radiation. The process of emission of radiation is called radioactivity. So the process in which they release radiations is known as a radioactivity, and that isotopes which emit energy is called radioactive isotopes. So simply, the radioactive isotopes are unstable isotopes. It means their nuclei is unstable. Their nucleus is unstable. So they decay over the time, and whenever they decay, they release radiations. So the process in which they release radiation is known as the radioactivity, and that isotope element which release radiation is known as the radioactive isotopes. Simple. So here is the example, like tritium. We already know about the tritium. It's a third isotope of hydrogen, which has which has one proton and two neutrons. So the overall atomic mass for the tritium is 3. So tritium H3 is a radioactive isotopes, and other two isotopes of hydrogen are stable. So the tritium is radioactive isotopes, means it's unstable, while the hydrogen and hydrogen and deuterium are stable. So they do not emit radiation, means they do not decay, they does not release radiations or energy. What's the chemistry behind radioactive isotopes? So simply they have unstable nucleus. How the nucleus is unstable? The main thing that make them unstable is the neutron. Actually, neutron is like a nuclear glue that hold the nucleus subatomic particles. Means they hold the protons and neutrons together to make the nucleus stable. But in some case, the combinations are stable, like in carbon 12. So the combination is stable, means the electron nucleus exists here, stay, while other decays over the time. While some combinations are unstable, so they decay over the time, like carbon 12. So some combinations in some case are not stable, so they are unstable and blast or decay over the time. The next topic is the radioactive decay. What's the decay, or what is radioactive decay? So the radioactive decay is simply the breakdown of the radioactive isotopes into some other fragments. In simply, the radioactive isotopes in the decay process decompose, maybe into one fragment, into two fragments, and release radiations. And with this, they release radiations. And the radiation process, is we already know, is the radioactivity. So in decay simply is a breakdown. When a radioactive element emits radiations, so whenever radioactivity occur, means whenever the isotope release radiation, it is transferred into another chemical element. Like this, it break into other chemical elements, and the process is called radioactive decay. These new elements that are formed after the decay may be stable or may be radioactive. Maybe means they may be stable or unstable. If they are stable, it means they are not radioactive, and if they are radioactive, it means they are unstable. So that it also emits radiation. If they are stable, so they stay over the time. But if they are unstable, means they are radioactive, So they decay over the time and also release radiations. Here is an example for the radioactive decay. Here, uranium. Uranium is a radioactive isotope that decay over the time and decompose into thorium, which is another element of the periodic table. So uranium break into thorium and also release energy, means they also release radiations. So it's a simple radioactive decay where uranium decompose into thorium and release energy or the radiations. This thorium compound is also a radioactive isotope. So it also decompose over the time. Thorium is unstable, means it is also a radioactive isotope, so it further disintegrate, decompose into to give protactinium. So thorium is also a radioactive isotope that decompose into protactinium and release energy. And protactinium is little bit stable, so it stay over the time. Here is another example like bismuth. Bismuth is also a radioactive isotope, so it decomposes into the thallium and releases energy or radiations. Here you can see a clear difference in their atomic mass and atomic number. Here 234 is the atomic mass, while the protactinium is 231 and 91. So there is a clear difference in the atomic mass and atomic number. The remaining amount of the protons and neutrons change into the radiations. So in the same way, here is 210 and 206. There is a 4 difference, while in this bismuth 83 to 2081 there is a 2 difference. So this amount of energy is released in the form of radiations. This is our today's lecture, in which we will study about the radioactive isotopes, how they decompose, what's the chemistry behind the radioactive isotopes and the radioactive decay. That's all. Next, we will discuss about the applications of the radioactive isotopes in the next coming video lecture. So stay connected with this YouTube channel and kindly subscribe and press the bell icon button to get the updates. Thank you.